Hi everyone, and welcome to the fourth video about the mathematics behind AI. And in this video we're going to introduce the Cartesian product of sets. Well, let's look at three sets, for example, A, B, and C. Well, how can I make a third set out of them? Or not necessarily all of them. For example, I can take the product of A and B, the Cartesian product, and I denote this by this squared x here. So this is a set, so I will use the accolades notation to determine its elements. Well, the elements, they look like, in this case, tuples A and B, because we're taking a product of two sets here. A tuple A and B for which it holds that, you guessed it right, A is an element of set A and B is an element of set B. So what we can see here, that it's not something like before, like the A, the union of B, that these elements are really like similar as the elements we have in A. We make something, we make a new type of elements in such a way. We make tuples here. Well, just as with rational numbers, you can add up multiple rational numbers, you can multiply multiple rational numbers, you can also take a multiple product, a Cartesian product of more than two sets. Yes, you can look at the Cartesian product of A, B, and C. So there are three sets here. So the elements will be three tuples, A, B, and C, for which it holds that A is an element of A, B is an element of B, and C is an element of C. Well, what we can already see from this definition, that also if A is not equal to the set B, then you can see that these sets are not the same. The product of A and B is not equal to the product of B and A. So this is, of course, if you multiply, for example, rational numbers, it's commutative, you can just switch the order. With sets, it's not. So that's already an important distinction. Now, what we often will use in the upcoming videos is we take A and B equal to the real numbers. And so we can, for example, look at the product of R with itself. So the elements we know now, these are all tuples with x and y real numbers. And why did I give you this example? Because you know that the real numbers, we can actually represent this as a straight line, but we have two copies. So what we can do, for example, to represent this, to give really like a geometric picture, we can draw a second line here, orthogonal to the first one, and we can say this is what we call the x-axis and this is the y-axis. And so every point in here, well, we can take the projection onto this x-axis, this gives a point A. We can take the projection of this point to the y-axis, this gives an element B. And I can say, well, this is the point P with coordinates, x-coordinate A and B. And what we see that, of course, that this point is just an element of R times R. So what we actually see is that R times R represents the plane. And this allows to do planar geometry. So for example, lines, straight lines, are actually subsets of R times R. Just to show you that everything we already saw in the previous videos will actually be used when you want to study planar geometry. If you want to say, well, okay, it's two-dimensional, R times R, two directions. Well, I actually want to do three-dimensional because, well, we live in a three-dimensional world. So of course, you can just look at the product R times R times R. So we know now three sets. So the elements are, well, let's use x, y, z. X, y, z are 3 tuples with x, y, z in R. And this again you can still represent with some imagination. This line goes inside the board. And this allows us, if you work in this set, you can do like spatial geometry. But of course, we are not restricted to only consider Cartesian products of 3 sets. We can also use, for example, work in R times R times R, and so on, and so on. And we can do this n times. And we just denote this as R to the power n. So with this notation, this is just R squared, and this is R cubed. Well, how do these elements look like? These are n tuples because there are n sets, x1 until xn, with xy in R for every I between 1 and n. And of course, we cannot imagine it ourselves anymore if n is bigger than 3, but it's not necessarily, because actually you also already know, you already know how to work with this. If you can, for example, if n equals 4, let me put that here. If n equals 4, and I want to describe some cities, and I want to give a property out of this, I can look at the population. I can look at the surface. I can look at the longitude. I can look at the latitude. So these are all numbers, x1, x2, x3, x4. These are 4 properties of a city. Whichever city you pick in the world, you can look these up. This will give you 4 real numbers. Well, they will be restricted. They will be positive, for example. But in any case, these are 4 numbers, so you can consider them as a 4 tuple. So this is just an element of R4. So you actually, maybe unconsciously, are already working in a 4-dimensional space. You cannot imagine it yourself. That's not important. Just realize, well, R to the power n elements of this are just n tuples. All right? Ciao.